Welcome to the first lesson in Section 3, titled Patterns and Relations in Tables. In this video, we're going to be examining patterns. So to start, we're going to complete this input-output table, which means we're going to input a value of n into an expression, and then we determine the output value. And this is going to be done in a similar process to when we were looking at evaluating expressions in a previous video. So let's start with n equals 1. The output expression that we're using is 5n plus 2. So let's go ahead and replace n with 1. So 5 times 1 plus 2. We'll do the multiplication first. 5 times 1 is 5, and then we'll add 2 to that, giving us 7. Now n equals 2. So we'll write 5 times 2 plus 2. Multiplying 5 and 2 to give us 10 gives us an answer of 12. Now let's look at n equals 3. 5 times 3 is 15. Adding 2 to that gives us 17. Now what if n was 4? What's the output value then? Well, 5 times 4 is 20. Adding 2 to that gives us 22. And lastly, when n equals 5, we have 5 times 5 being 25, giving us an answer of 27. So we're going to be looking at some completed input-output tables and then trying to figure out what expression was used to create those values. So let's have a look. Here we have to describe the relation between each set of numbers. So look at 1 and 4, 2 and 5, 3 and 6, 4 and 7, 5 and 8. So you can look at the top row, the x values, as being the input, and the bottom row, the y values, as being the output. So when you input 1, you get an output of 4. You get input 2, you get an output of 5. What do you notice about these values? Well, the values of y are 3 more than the values of x. So just look at an x value of 4. If you add 3 to that, you get 7. If you add 3 to 5, you get 8. So that's the relation between the x and the y values here. Let's do that again. We're going to describe the relation. Now this time, because the table is written vertically, we'll be looking at these sets of numbers, 1 and 3, 2 and 6, and so on. So what do you notice about x and y values here? Well, you may notice that the values of y are triple the values of x. If you look at the next value of 3, you multiply that by 3, you get 9. If you multiply 5 by 3, you do get 15. So that's the relation between x and y here. The x values are multiplied by 3. So now, instead of just describing the relation, we're actually going to come up with an equation. So here I have the input values being t, 20, 21, 22, 23, 24, and the output values are k, 18, 19, 20, 21, 22. So what kind of relation do you notice between t and k? 20 gives you a value of 18. 21 gives you a value of 19. Well, you may notice that the k values are 2 less than t. Since all the values are 2 less, you can say that the k values are t minus 2. Now that we got this relation, it can be used to find the k value for any value of t. So let's just say we wanted to find the value of k when t equals 30. Well, we can just go ahead and replace t with 30. 30 subtract 2 gives us a k value of 28. So the advantage of creating an equation is that it can help you find any value. So now let's look at this relation. Again, we have some t values and we have some k values. What equation can be used to describe the relation here? So you may notice that adding a certain number onto all the t values doesn't work, or multiplying a certain number doesn't work. This one, there's going to be a combination. The equation is this, 2t plus 3. So how would we figure out this type of equation? Well, you're first going to determine what the bottom row increases by. So let's have a look. The values go from 3 to 5 to 7 to 9 to 11. So you may notice that they increase by 2's. So that's where this 2 value comes from in the equation. So after you figure out what it increases by, then what do? Well, plug in a value of t into the equation, k equals 2t. So any of the values that you see in your table, 0, 1, 2, 3, or 4, plug in one of those. So I'm going to plug in t to be 1. Now 2 times 1 is 2. Now when I look at my table of values, when t is 1, I should get a k value of 5. Now in my little equation, I have my k value being 2. So what do I need to do to adjust my equation in order to get a value of 5? I can add 3. So that's where this plus 3 comes from in the equation. So you have 2 steps to follow. You have to figure out what the output values increase by, and then you plug in a value, and then figure out what number needs to be added or subtracted to that. So let's practice those steps with this example here. So we'll start with determining what the right column increases by. So if you look at the numbers, 4, 7, 10, 13, 16, you might notice that they all increase by 3. So you start off with the equation, k equals 3 times t. Now let's plug in a value of t into the equation we just created. So you can plug in any value at all. Last time I plugged in 1. This time I'm going to plug in 2. So now if I work that out, I get a value of 6. So now if I look at the table for when t is equal to 2, my k value should be 7. Meanwhile, in the equation I wrote, I got 6. So we need to think, how can I change the equation to make that 6 into a 7? Well, if we add 1, that would certainly do the trick. So that means our equation becomes k equals 3t plus 1. Now, a good idea is to always check your answer by replacing t with a different value to make sure it works. Now you can move on to the next video in this lesson, where you will continue to practice creating equations.